So today we are going to learn differential amplifier. Main purpose of the differential amplifier is to provide high gain to different signal and cancel the common mode signal. So main purpose is to provide high gain to difference signal and cancel common mode Now what is difference signal and what is common mode signal, it will be clear after discussing the circuits and details. So first come to the circuit. The circuit consists of a pair of transistors. So as you can see that we have two paths, two identical paths. We have two supplies, plus VCC and minus VE, and the current through each branch is IC1, IC2 and IC1. This name of this transistor is Q1 and Q2. A signal is applied here at the base, that is V1. V1 signal is applied at the Q1 transistor base, and V2 signal is applied at Q2 transistor base. Due to V1 and V2 signal, you have currents through RC is IC1 and this RC is IC2. Now there are four kind of configurations. One is differential input, differential output. So these two are the inputs. So in this amplifier we have two inputs, one is V1 and V2, and we have two output, namely that output may be V01 and that output may be V02. So based on this, you have four kind of configurations. Whenever you have both inputs and both outputs, you take difference of the output and you take difference of the input, that is differential input, differential output. So in differential input, differential output, you will take the difference of the input as input and difference of the output is output. Differential second is, first one is differential input, differential input, differential output. So in this case you take the difference of the input and output you take as difference of the V01 and V02. Second kind of configuration may be differential input and single output. So you apply input at both bases V1 and V2 and you take output from one of these two collectors, maybe V01 maybe output. So in this case differential input means you apply a input at both the bases and collect the output from any of the collectors. Third configuration may be single input differential output. So in this case, you apply any of this input and connect other input to maybe ground or any other potential, and collect output as the difference of the signals. Maybe output V0 is V01 minus V02, and you may apply input at any of these two inputs. So that is the single input. So you apply any of these signals and take the output as a difference of these outputs. And fourth is single input, single output. In this case, you apply any of the input, other input would be grounded, and take output from any of these collectors. So that will be single input and single output. Now let's discuss the working of this differential amplifier. Now let's discuss the working of the differential amplifier. So that is our differential amplifier. Let's assume that both the inputs are shorted together. Let's assume both the inputs are shorted together and connected to a single voltage, that is VCM. So as a result, if I assume both the transistors are identical, so both the transistors are in same voltage conditions. So that means these two emitters are shorted together, two bases have same voltage, and the collector have identical RC values. So as a result, you have same amount of current flow through each branches. So this total current through this may be IQ. Total current through RE is IQ. So because of this symmetry, this current will be equally divided among the two transistors. So that current will be IQ by 2. Emitter current will be IQ by 2 for the first transistor. For the second transistor will be IQ by 2. If I assume the transistor having parameter alpha, that is common base amplification factor alpha, so if emitter current is IQ by 2, base collector current will be alpha times IQ by 2, and that current will also be alpha times IQ by 2. So as a result, if I consider the voltage will be VCC minus this drop. So it will be V02 will be VCC minus alpha IQ by 2 RC. Similarly, V01 will be VCC minus alpha IQ by 2 RC. And you can see both the terminals have same potential, so their difference will be 0 in this case. So in this case, IE1 is equal to IE2 is equal to IQ by 2. V01 is equal to V02 is equal to VCC minus alpha IQ by 2 RC. As a result, you have V01 minus V02, which is the differential output signal, equal to 0. Now consider another case.